Good afternoon. We will be studying Chapter 7, Part 4, Application of Logic. Here we'll study the application of logic in computer science. Now, what do you understand by computer science? Computer science is the study of computers and computational system. What do you understand by this? It deals with computers and mathematical calculations. The most important aspect of computer science is problem solving, which is an essential skill for life. It is the study of the design, development, and analysis of software and hardware used to solve problems in variety of business, scientific, and social context. Let us see what a computer is. Computer is an electronic device for storing and processing data, typically in binary form, according to the instructions given to it in a variable program. It is most important invention of 20th century. Computers have influenced our life to a great extent. They are used at almost every workplace and home. It has become almost indispensable in modern man's life. That is absolutely necessary. Means one cannot do without computers. As you have seen in COVID-19 pandemic situation, almost in every field, people had to rely on computers. You know that even the educational field, though computers appears to be superior to man, it cannot think and reason like man. It can only perform when instructions are given to it. It is a brilliant invention because it is faster, accurate, and consistent than man. It can also do multiple tasks at one time, and unlike man, it can function continuously for hours. Now let us see, how does a computer works. It can perform tasks and solve problems by carrying out instructions given to it. A sequence of instructions describing a certain task is called program. What is a program? A program is a set of statements of a language which the computer can understand, and the language is called a machine language. There are various machine languages of computers like COBOL, Unix, HTML, etc. Knowledge of principles of logic is necessary for making computer program. Computers' instructions to perform operations are given only in the machine language. The computer uses binary system for its operation, which are only two digits, that is 1 and 0. As in Boolean logic, the values of variables are true or false. The information which is in language is coded in binary digits to feed it to the computer. After processing, the output given by the computer is also in binary digits, which is displayed on the screen by converting it into language. A computer thus receives, stores, and manipulates information composed of only 1 and 0. The manipulation of binary information is done by logic circuits known as logic gates. Every circuit in a computer has input and output, which is effectively a type of information that can be represented by on or off electrical signals, 1 or 0, that is 1 or 0. In order to process the information that come in as input and to make the information that is output, a computer needs to modify and combine the input signals. In simple circuit, we have one input and one output. It takes an electrical signal as on or off, that is 1 or 0. If the signal is on, that is 1, it flips its output as on, that is 1. If the signal is off, that is 0, it flips its output as off, that is 0. But if the logic gates are manipulated, that is the circuit is modified, then they will give different results. Let us take the circuit where we have one input and one output. If in this circuit the signal given by the input is 1 and the circuit flips its output as 0, and if the signal given of input is 0 and the circuit flips its output as 1, then the signal that goes in it as input is not the same as the signal that comes out as output. Such a circuit is called as NOT gates. This is similar to the truth table, the basic truth table of negation. A negative proposition is true when its component is false, and a negative statement is false when its component is true. Thus, it uses truth functional logic. More complicated circuits can take multiple signals and combine them to give more different results. Example of circuits with two inputs and one output will take two electrical signals. Each might be on or off, that is 1 or 0. Now let us see the circuit with two inputs and one output. In this circuit, if either of the signals coming in as input is 0, then the circuit will flip out its output as 0. And the circuit will flip its output as 1 only if the first signal, which is the input, and the second signal, which is the input, are both 1. We call this circuit as AND gate. This is similar to that of the basic truth table of conjunction, which states that a conjunction is true when both the conjuncts are true, and it is false when at least one of its conjunct is false. So it uses the basic truth table of conjunction. Now let us see another circuit with two inputs and one output. In this circuit, if either of the signals coming in as input is 1, then the circuit will flip its output as 1. And the circuit will flip its output as 0 only if the first signal of input is 0 and the second signal is also 0. So this circuit is called as OR gate. This is similar to the basic truth table of disjunction in truth functional logic. Your computer also uses exclusive OR gate in the circuit. There are many small circuits like that which perform simple logical calculations. By connecting these circuits together, we can make more complex calculations like addition, subtraction, multiplication, etc. Each individual operation done by a computer is so very simple that it could be done by humans. But these circuits inside computers are way faster than humans. Today's circuits in computer are microscopic but much faster and can perform billions of operations per second. So whether you are playing a game, recording video, or exploring the world, the information is processed extremely quick. Binary signals turn into websites, videos, music, games, etc. These circuits can even diagnose and cure diseases. To solve any problem in the computer, the programmer provides a method to the computer. It is in the form of a procedure, which is a series of steps in a logical sequence. This is called as algorithm. Algorithm is expressed in the form of a flow chart, which is essentially a diagram that defines the procedure. A flow chart shows the order of operations and the relation between the sections of the programs. Flowcharts are independent of a particular computer or computer language. There are some standard symbols used in drawing a flow chart, which is as follows. First is the start or the end button, then we have input output button, then we have processing, and last is decision logic. Let us take an example of the flow chart to calculate the sum of two numbers. The first is the start button, the second is the input, that is A and B, the third is the sum is equal to A plus B, and fourth is the print button, and last is stop. This is how the flow chart is used in computer. Logic recently is used in artificial intelligence. What is artificial intelligence? It is a wide-ranging branch of computer science concerned with building smart machines capable of performing tasks that typically require human intelligence. Efforts are being made to replicate or stimulate human intelligence in machines. There are four approaches of artificial intelligence. First is thinking humanly, thinking rationally, then acting humanly and acting rationally. The first two ideas concern thought processes and reasoning, while the others deal with behavior. Predicate logic is the backbone of artificial intelligence. Propositional logic is the logic that deals with a collection of declaration statements which have truth value, that is true or false. And predicate logic is an expression consisting of variables with specific domain. It consists of objects, relations, and functions between the objects, also known as Boolean logic, which is very useful in artificial intelligence. Artificial intelligence has acted as the main driver of emerging technologies like big data, robotics, and internet. And it will continue to act as a technological innovator for the foreseeable future. You have already seen in Bangalore, there are robots who are acting as a teacher in the school. They teach the students. So now logic has become the backbone of computer science. You have learned how logic is used in computer science in this session. Thank you.